Now, one of the things that's different from what we were doing in the past about solving some basic kinds of trigonometric equations is that there is a little bit of algebra involved in this process. So let's consider an equation like this one. We have 4 times the square of the sine of x minus 1 is equal to 0, and we want to find all the values of x on the interval from 0 to 2 pi that makes that true. Now, if you recall, in algebra, if we had a similar sort of situation, we might have said, well, if I had 4 times u squared minus 1 equal to 0, how would I solve for u? Well, I would subtract 1 from both sides, and then I would divide both sides by 4. And in this equation, if I wanted to solve for u, I would take the square root of both sides, but you'd have to remember that that means we're going to get positive and negative values of the root of 1/4. In this case, our square is an unknown, so both positive and negative values work. And we would have said, well, then u is equal to positive or negative 1/2. Well, the same is true here. In this case, our equation 4 minus sine squared x reduces to, like it did over here, the square of the sine of x equals 1/4. And therefore, when we take the square root of both sides, we're going to get both positive and negative values to contend with. And so sine of x is reduced, or our equation is reduced to sine of x is equal to positive and negative 1/2. Now, in the last example that I gave, we dealt with sine of x equals 1/2 by recognizing that on the interval from 0 to 2 pi, in quadrant 1, x equals pi over 6 was one such value. And we could draw a right triangle to represent that situation yet again right here. Pi over 6 is the angle whose ratio of opposite to hypotenuse is 1/2. And we also found that that was true for quadrant 2, because in quadrant 2, sine is also 1/2, and we found our value by taking pi over 6 as the reference angle within that unit circle. And if this is pi, pi over 6 subtracted from pi gives us the angle 5 pi over 6. So 5 pi over 6 was our other angle. But now we have a new value added to this one, and that is, where does sine of x equal negative 1/2? Now, the problem with sine of x equaling negative 1/2 is that we can't exactly use our arcsine function, because we know that if we take the arcsine of negative 1/2, we will get negative pi over 6. Negative pi over 6. And negative pi over 6 is not within the range of values that we're interested in here. We wanted to find our values on the interval from 0 to 2 pi. So what do? Well, we recognize that in the fourth quadrant right here, pi over 6 is contained as a reference angle. Right? We might say negative pi over 6 in there if we rotate clockwise. But we recognize that negative 1/2 to 1 is the ratio for the sine. And so in quadrant 4, if we wanted to find our angle, we could say our quadrant 4 angle is going to be 2 pi minus pi over 6. So another of our values right here would be 11 pi over 6. But then there's one more angle, because we know that sine is the kind of angle that has negatives in both quadrants 3 and 4. So let's go here to quadrant 3 and use our reference angle yet again. If we put the angle pi over 6 in that reference and we add it to pi, so our quadrant 3 angle is going to be pi added to pi over 6 this time. And so we might find our value this time at 7 times pi over 6 when we put that together. So our solution set this time consists of 4 values. And we always want to answer these in order, by the way. I always line them up from smallest to largest. Pi over 6, 5 pi over 6, 7 pi over 6, because it's in the third quadrant, and 11 pi over 6. All of which are values who, when we substitute into the original equation, 4 times the square of the sine of x minus 1 gives us 0. And so we're done.